All right, so we're starting our last topic before we move to reviewing for the test. It's just another type of version of what we've already been doing in terms of evaluating equations. So we've talked about input output. Now I gave you a input output chart table. So what you're going to do is you're going to figure out which one of these equations matches this chart. And the best way to do it is to use the fact of input output. So all the x values are input values. So what we're going to do is we're going to take these input values and plug them into these equations for x, and whichever one matches this table, that is our solution. So I'm going to show you what to do on the first equation. I'm going to use this equation first. So I'm going to start out with y equals 7 plus, and same rule, anytime I plug something in for x, I'm going to use parentheses. And let's see, so the first x is 1, and so 7, 5 times 1 is 5, and that gives me 12. Now how do I know if that's right or not? Well, I'm looking down here, my output, which is my answer, should have been 11. So I know that marked out the wrong one. I know that that is not a possibility. Okay, so I'm going to do the same thing for the next equation. So I'm going to try the same thing. I'm going to go y equals 7 plus 4. I'm going to plug in 1 again. I get y equals 7 plus 4. Y equals 11. All right, so do not, just because you got one answer correct, do not assume that that is always going to be the right answer. And here's why. I'm going to skip over part C and just go ahead and tell you that that does not give you the right answer either. But look at this. When I plug in 1 into this equation, it also gives me 11. So how do I decide which one is the correct answer, B or D? Well, here's how. You need to plug in more than just one input. So I'm going to start and I'm going to do a second input. I'm going to try 2. So when I plug in 2, 7 plus 4 times 2 is 7. 4 times 2 is 8. Y equals 15. All right, good. When I plug it in over here, y equals, first check, go back, yes. When I plugged in 2, when I put in an input of 2, it gave me an output of 15, so that is good. So let's check this one. 8 plus 3 times 2, y equals 8 plus 6, y equals 14. Now, when I plugged in the input of 2, it did not give me 15. So that is not a possibility. It has to work for every single one of these. It cannot just work for one, because D worked for an input value of 1, but it doesn't for the other ones. B works for all of them. So B is our correct answer. And that's how we're going to use an input-output table to solve these type of problems. You use the input-output table to determine which equation matches that table by plugging them in. All right, next, a function. Now, we've been dealing with functions, and you're used to dealing with functions in terms of equations, but right now I'm going to give you one in terms of a graph. So let's try to make this make sense. This is our equation, except for it's in terms of a graph. So I gave you f of x. Here is the graph, is f of x. I want you to find f of negative 1. Now, how do I do that? So what happened here? What changed? We talked about this before. Well, the x turned into a -1. Good. So you're going to look over here on the x-axis. Okay? This is my input value. This is what I'm plugging into the function. So I'll look over here on the graph, and I go to -1 on the x-axis, which goes from left to right. Now, here we go. Starting here, and what I'm going to do is I'm going to go up, up or down until I can touch the graph. This is the graph. And so when I go down, when do I touch the graph? Right here at -5. So my solution is -5. All right, let's do one more. All right, I'm going to go, so my function, what I'm trying to find is f of 1. Can you show me what you think f of 1 equals? Okay, here's what I'm going to do. You're going to go right 1, because it's replacing the x. You're going to go to right 1, because it's a +1 on the x-axis. And this one also I'm going to go down, and I'm going to touch the graph right here. Well, where did I touch it at? Looking across, right here, it's at -1. So my solution is -1. And those are the last two things we're doing with functions and evaluating functions.